Functional programming is all about the separation of concerns, meaning separation of data and functions. Instead of focusing on changing the state and mutable data, we shift our attention to composing functions and processing immutable data structures. It's a paradigm that encourages us to break down complex problems into small, manageable pieces. In functional programming, we don't combine data and functions into one object. Instead, functions operate on well-defined data structures, like arrays and objects, rather than belonging to that data structure, like being a method of class or object. The main goal of functional programming is to write software in a declarative and pure manner, which will make our code clear and understandable, easy to extend, easy to maintain, and memory efficient. One of the key concepts in functional programming is the idea of immutability. We treat data as unchangeable, and instead of modifying it directly, we create data structures based on the existing ones. This approach ensures that our code is more predictable and leads to fewer bugs. The main pillar of functional programming is pure functions. There are two main rules that a function should follow to be called a pure function. The first rule is that it should not have any side effects. The function can't modify anything outside of itself, which means that it shouldn't modify any of its arguments or global variables. Instead, it must create a copy of that data and work on that new data. And the second rule is the referential transparency, which means that it has to always return the same output for the same input, and it shouldn't rely on any external state. But can everything be pure in our code? The short answer to this is no. The goal of functional programming is not to make everything pure functions. The goal of it to minimize side effects and be predictable, composable, to have immutable state, to not share state between functions, to try to keep them pure, to return statement from our functions, and ideally each function should do only one task. Now let's talk about the benefits of functional programming. By embracing this paradigm, we gain access to powerful tools and techniques that can enhance our development process. One of these tools is higher order functions, which allow us to create reusable and composable code blocks. Higher order functions are functions that take other functions as an argument, or they return a new function. We can pass functions as arguments and return functions from other functions, which unlock the power of composition. Composition is the idea that any sort of data transformation that we do should be obvious. Let's compare it with the more traditional imperative programming, where we focus on describing the steps to achieve a desired outcome. Imagine we have a task to filter out even numbers from an array. In imperative code, we would explicitly write the steps of how to achieve this. We would iterate over the array, check each element, and add even numbers to a new array. This code tells the machine both what to do and how to do it. However, in declarative code, we focus on desired outcome rather than the steps to achieve it. With functional programming, we can use higher order functions like filter to express our intent concisely. We simply declare that we want to filter out even numbers from the array, and the underlying implementation takes care of the how. Declarative code will always be compiled down to imperative, machine code, But it's easier for humans to read and understand declarative code over imperative one. Thanks for watching and see you next time.